Hey guys, welcome back. This time we will be learning a new physics concept called heat and energy. What is it about? Let's hit the ground running. So the first part that you will need to understand what is the main difference between heat and temperature, right? Heat, heat all the time is going to be related to a system, right? Is how much energy is transferred or how much temperature is transferred from a hotter to a colder system. Okay, then that's the main rule. Is that a system is going to transfer the energy to another system, right? That's heat. How much temperature was transferred to the new system, right? And regarding the global energy that the heat will be transferred from hotter to colder. That's the main point, right? So we need to understand this concept. Teacher, I cannot grasp this yet. You might explain to me this in another way? Of course, baby. Let's hit it ground running over again. uh, in this case, we will need to understand that the heat is not for just one object, right? Heat is going to appear when an object wants to transfer the energy or the temperature to another. That's called energy transfer. Then, when you transfer the energy to another object, the main point here is that you are transferring energy, right? You're transferring certain kind of kinetic energy, right? That's why if I have a lot of kinetic energy, the real meaning of this is that I will have a increased temperature or a high temperature, right? Because they are directly proportional between the temperature and how much kinetic energy do we have, right? More kinetic energy, more temperature. If I, less kinetic energy, less temperature, right? That's the main point. Then that's why that's something that need to be that's something that need to be understandable, right? And that's something that needs to be understood as well, right? Then in that case, if you have got some questions about this, let's do the board. It's time to go to the chat, right? So it's time to crack the books. Let's go to the chalk to have a better view or to have a better understanding on this, right? Let's go. Now let's have a better view. Now we were talking about the temperature. It's all the time related to how much kinetic energy do we have, right? In my system, right, or in my object. In this case, that's why the temperature is the measure of average kinetic energy, kinetic, kine, this energy of particle, kinetic energy of particle, right? All the time it will be related to kinetic, right? Nothing else. What are the scales? Celsius, Fahrenheit, and Kelvin, right? Now, those are the main conversion equations, right? And it's a piece of cake to use. Then you don't have nothing to be concerned about, right? And the first part is about what's the meaning of heat, right? And as we can check here, is transfer of thermal energy due to temperature, right? Then if I want to transfer my energy or my temperature, I just need to I just need to have someone beside me, right? Here. And by contact, my temperature that is hotter will be transferred to a colder system, right? This colder system is that's the main point, right? That is from hotter to colder, right? Now here was the main equation here. Later, or we will be grasping this, we will need to understanding that is the difference in the temperature or the temperature difference. Here is how much heat the object does have, and here is the mass, right? Then we need to we need to achieve these exercises. Let's do it. It's a piece of cake, right? There are just multiplications, right? There's something like that. Here, I'm staying here. 25 Celsius, right? Celsius to Kelvin. 100 Celsius to Fahrenheit. And what are the equations? The equations are here. This is the first equation. And we will need this. C is Celsius, right? How much Celsius? How many? Right? How much? No. How many? How many Celsius? Right? And here, that's a constant, right? It won't change never. And this is another constant. Here, the equation is saying that the Celsius plus 273.15 it's equal to Kelvin. Then I am here requesting you to achieve this from 25 Celsius to Kelvin. Then it's pretty simple. 25 Celsius, right? To Kelvin. The main equation is this. Kelvin equal 25 Celsius plus this. And you gotta assume by yourself, right? The answer would be this, but in Kelvin, right? It's just a multiplication, and no, there's no multiplication here, just a basic sum. You just have to learn this, to memorize this, right? And now this is equal 298.15. Now let's convert from 100 centigrade, this is 1, right? 200 Celsius to Fahrenheit, right? The equation, it's no harsh, right? It's not harsh to understand. It's just Fahrenheit is equal P plus 32. Here, Fahrenheit, it's equal. What is this in centigrades? The Celsius here. Here, 1.A plus 32. Here, this with this, annihilate, and this by this, 10 by this equal this, right? Then the reality of this is this, plus 32. Then here is right, Fahrenheit, right here. You just have to understand the basic equation, right? So you gotta do your own examples using this formula because it will be assessed on your last assessment, right? Then if you have got some doubts about how you can use this, please don't hesitate to ask them on the comments below. And if you have like this, and we are going to continue to the next level. Then don't move. Okay, guys, we came back. And now here we have more conversion equations, right? Here, that's the opposite from Celsius to Fahrenheit. Now from Fahrenheit to Celsius, right? Here from Celsius to Kelvin. Here from Kelvin to Celsius. Here from Kelvin to Fahrenheit. And that's the main point, that we need to mix the scales, and we have certain conversions regarding certain problems, right? Let's do it. Then we have to, I'm going to convert here, right? From 1 Kelvin, 100 Kelvin, right? How much is 100 Kelvin? 100 Kelvin in Celsius, 100 Fahrenheit. Start it up. Minus 32, multiply it by this, right? Then the answer would be 38. It is divided 9, right? Then here, what can you do here is the multiplication of this is going to be 40, 54, right? 340 divided 9. Like 6 something, right? You got to do it by yourself. That's the answer, right? That's the answer, right? I don't think. I'm not going to do. Right? Then if you got this answer, you can do something. Like you can say that 100 of Fahrenheit, 100 Fahrenheit is the same of 340 divided 9, right? Then if you want to know how much is this, please figure it out by yourself. And the answer is 37.777 periodically, right? Then that's 100 Kelvin. We have already used this, right? And now we have to use this. Everyone is going to be converted from 100 Kelvin, right? 100 Kelvin minus this, right? That's pretty simple. That's just a basic operation, right? Minus, right? Because here that's the minus amount. Good. Now here's 1 exercise, 2 exercises. Now we are going to use this. Fed. 1, 2, 3, right? Here to Fahrenheit from 100 Kelvin, right? Minus this. Here this. Plus this. Recall, all the time you're going to achieve or to complete first, all the time the multiplication, later the sum, right? That's something basic. Also, you will need to resolve first the operation that is within parentheses, right? That's something important for you. And by the way, give me my like, right? If you have like this, comment this and comment your doubts and follow me, right? Now here, it's equal this minus, right, P Now, this plus 32, right? We have to multiply this. Let's do it. We have already solved this. The answer is minus 279.67, right? Why minus? Perhaps you are wondering yourself, why minus? Because you gotta recall that the equation is staying Kelvin minus 273, right? 273, and here is minus 173, right? This multiplied by 1.8 plus 32, it's equal minus 279.67, right? That's how we can use the equations of the convention equations to transfer, to mute, or to combat certain temperature measures, right? So let's resume this. The temperature. What's the temperature? The temperature all the time is related to kinetic energy. Kinetic, more. If you have more kinetic energy, more temperature or higher temperature, right? That's the proportion, right? More. There's a direct proportion, right? If this increase as well. But what about a heat? If you have not understood this yet, I'm going to resume this immediately. Heat is all the time related to two systems in contact. It's not related to one, right? We cannot be talking about heat in just one object, right? Because the heat is product of one object that has contact with another object, and that's why it is called heat, because it's transfer of thermal energy due to temperature, right? I'm going to transfer my temperature. Then we can conclude that the heat is product of temperature, right? Conversion, or the temperature transfer, right? Then that's the main point of this. Okay, if you got some questions about this, don't hesitate to ask them on the comments below. If you like this video, give me my thumb up, and please follow me, and see you at the next class. We are going to be starting 1, 2, 3, 4, 5. We have learned 5 ways to combat the temperature. So if you wanna learn more, hit the bell. See you at the next class, and record this. It's time to crack the books. See you at the next class. Have a good one.